Welcome to the deep dive. I'm so thrilled you're joining us today because we are looking at something that honestly feels like it's been ripped straight out of a science fiction novel.
Yeah, except it is happening right now.
Exactly. It's March 2026, and we are stepping into this massive futuristic shift in how the world actually works. We've got an incredible stack of notes and photos to go through today.
Centered entirely around this huge shift in the American workforce, driven by Amazon's robotics program.
Right, and looking through these photos from a Seattle fulfillment center, you get an immediate sense of the scale. Amazon they quietly crossed a massive red line.
1 million.
Yeah, they've officially hit over 1 million active robotic units operating in their logistics network. 1 million.
It's a staggering number.
But the sheer number of machines zooming around a warehouse, that's not the real story here. The real story is that artificial intelligence has fundamentally evolved.
We aren't just talking about a digital chatbot on your screen composing emails anymore.
No, we are talking about physical machines that can actually think for themselves in the real world. Okay, let's unpack this.
What's fascinating here is that we're looking at a qualitative leap, not just a quantitative one. Hitting 1 million robots is a huge logistical milestone, sure. Industry projections didn't even anticipate this level of physical integration for another decade.
Right, they were way off.
Completely off. But the real leap is in the nature of the machines themselves. We are witnessing the birth of agentic AI in the realm of physical logistics, and it changes the entire definition of what a robot actually is.
To really appreciate how wild this is, you have to picture the old way these warehouses operated. If you think back even just a few years, warehouse floors were a very different environment.
Very manual.
Yeah, gone are the days of workers constantly walking the aisles with manual scanners, and gone is that simple hum of basic guided carts. Think about the older generation of robots like those early Kiva models.
Right, the flat ones.
Looking at this first image from the Seattle facility, you see one of these older Kiva-style bots. It looks almost like a giant robotic hockey puck sliding under a shelf. And the way they operated was fundamentally limited.
Because they were confined by their programming,
Yeah.
right, and their environment. Those older path-following robots were incredibly efficient at lifting and moving, but they were trapped in caged-off areas.
Fenced right in.
Literally navigated by strictly following a grid of barcodes stuck to the warehouse floor, or by following rigid pre-programmed digital tracks. They were completely blind to the dynamic world around them.
Imagine you drop a box of inventory in front of one of those old Kiva robots. It wouldn't try to go around. It wouldn't know how to solve the problem.
It would just stop dead in its tracks.
Just stare blankly ahead and wait for a human being to walk over, pick up the box, and clear the path. They were strictly path followers. But this new fleet rolling out across the country, they are world perceivers.
Yes, exactly.
I was reading through the technical breakdown of how these new machines operate, and it mentions they are powered by multimodal transformers. Now, that sounds like a heavy piece of jargon. How does that actually differ from the AI we are all used to playing around with on our laptops?
Think of the generative AI you use on your computer as a brain trapped in a jar.
Oh.
It's brilliant at processing language, but it can only communicate through a keyboard and a screen. It generates words based on text prompts. Multimodal transformers essentially give that brain eyes, ears, and hands.
So it's perceiving the actual environment.
Right. Instead of processing text, this agentic AI takes in raw, continuous sensory perception from the physical world. We're talking about high-definition computer vision, LiDAR.
Which is the pulsing lasers, right?
Yes, lasers that measure exact distances and map topographies, plus highly sensitive tactile data. It translates all of that sensory input directly into physical movement, much like your own brain tells your hand to catch a falling ball.
It's processing the physical world in 3 dimensions continuously. And the notes mention this all happens through a continuous loop. It doesn't just receive a blind command from a central computer saying, drive to shelf B4.
No, it's constantly adapting.
It runs this rapid cycle of seeing, predicting, and deciding. Break that loop down for us, because that seems to be the core of what makes agentic AI so different.
It's a 3-step process that happens in milliseconds. First, it sees. The robot uses those multimodal transformers to constantly identify every single element in its environment.
Just taking everything in.
Exactly. It categorizes moving obstacles, like a human worker carrying a scanner or another robot crossing an intersection. And it identifies fixed obstacles, like a spilled pallet of goods or a forklift parked in the wrong spot.
It is mapping the chaos of a warehouse floor in real time.
And once it maps that chaos, the second step is that it predicts. This is where the machine learning truly separates itself from simple automation. If the robot sees you walking down an aisle, it doesn't just track your current coordinates.
It figures out where you're going.
Right. It calculates your trajectory and your walking speed. It anticipates where you are going to be in 3 seconds or 5 seconds. It's running hundreds of probabilistic models instantly to ensure it doesn't cross your path, cause a bottleneck, or create a safety hazard.
It's essentially playing a high-speed game of chess with its physical environment, constantly looking 3 moves ahead.
Precisely.
And that leads to the final step of the loop, which is the decision-making part. Let's go back to that scenario where an aisle is completely blocked off by a spilled pallet. Under the old Kiva system, the whole zone might stall out. But with the decide phase, this new robot handles it autonomously.
That independence is the hallmark of physical agency. The robot assesses the blocked aisle and autonomously decides to pivot its entire workflow.
On its own.
Completely on its own. It calculates a new route, or it decides, I'll go pick this item from an alternative shelf on the other side of the building. Or even, I'll deprioritize this order and start working on an entirely different shipment for now.
That's wild.
And it does all of this without needing to ping a central server and wait for permission. The problem-solving process is completely decentralized down to the individual machine.
Here's where it gets really interesting, because we aren't just talking about those flat, hockey puck-style robots anymore. When you look at the photos from the warehouse floor, you immediately notice the specific, highly autonomous models leading this revolution.
The new workforce.
These are the metal coworkers of 2026. The first one that jumps out from the Seattle facility photos is this massive, sleek machine called Proteus.
Proteus represents a complete reimagining of spatial logistics. It's a heavy-lifting, omnidirectional machine. While it might share some functional DNA with the older warehouse bots, it still moves heavy racks of inventory. The core distinction is how it interacts with the space and the people around it.
The visual contrast in these photos is striking. On one side of the facility, you can see the remnants of the older systems, heavily fenced in with thick yellow metal cages to keep humans out of the danger zone.
The human exclusion zones.
Exactly. But then you look at Proteus, and it is gliding freely through the open floor. There are no physical safety barriers. It is completely uncaged.
Which fundamentally changes the architecture of the modern warehouse. Because Proteus can safely navigate around humans using that C-predict decide loop we just discussed, Amazon is unlocking a hybrid logistics model.
Sharing the space.
Right. You no longer have to segment the building into human zones and robot zones. Human workers and heavy-lifting multi-ton machines are now sharing the exact same square footage, seamlessly weaving around each other without the machine constantly shutting down in a panic.
As impressive as Proteus is, it isn't the most startling visual we have. That title definitely belongs to Digit.
Oh, Digit is fascinating.
Digit is a humanoid-style robot developed by Agility Robotics, and it is explicitly designed to work shoulder to shoulder with humans. When I say humanoid, I mean it has a very distinct head-like sensor array, articulating arms, a torso, and a pair of legs.
The decision to build a robot with legs instead of wheels or tracks is highly intentional. Our entire world, our stairs, our walkways, our shelving heights, has been custom-built over centuries to accommodate the human form.
That makes a lot of sense.
By deploying a bipedal humanoid robot, logistics companies don't have to spend billions retrofitting their warehouses to accommodate the limitations of a machine. The machine is built to accommodate the environment.
Looking at this photo of Digit in action is almost surreal. It has this sleek, metallic, slightly utilitarian sci-fi aesthetic, but it's performing the most mundane, everyday task imaginable.
Just moving a box.
Yeah, it's standing in an aisle, reaching out with these specialized robotic hands and grabbing a standard cardboard box right off a metal shelf. It crouches down, bending at the knees to pick up items from the bottom rack, and then seamlessly pivots to place them onto a moving conveyor belt. It mimics human movement with startling accuracy.
Seeing that level of sophisticated mimicry naturally forces you to look at the massive capital expenditure behind it. We have to examine the motivations driving the deployment of such advanced technology at this exact moment in time.
Which brings us to the trillion-dollar question. I want you to pause for a second and think about this. Why would a major corporation choose to invest billions upon billions of dollars to completely tear down and rebuild their logistics network with humanoid and agentic robots right now? Why is 2026 the tipping point?
If we connect this to the bigger picture, the data points to a set of brutal economic realities driving this shift. It essentially comes down to two immense colliding pressures: the surging cost of labor and the insatiable expectations of the consumer.
Let's break those drivers down, starting with the consumer expectation side, because that hits close to home. The reality is that the American consumer, and let's be honest, this likely includes you and me, now demands what the industry calls sub-60-minute delivery for everyday essentials.
We all do it.
We've all been there. It's 11 p.m., you realize you're out of toothpaste, you tap a button on your phone, and you expect it sitting on your porch before midnight. We treat logistics like magic.
But that magic requires immense physical labor. The logistics industry has realized that human bodies have simply reached their absolute physical limit for speed and efficiency.
We just can't move any faster.
You cannot ask a human being to run faster down an aisle or lift heavier boxes for 8 hours a day without literally breaking their bodies. The physical threshold of human labor has been maxed out.
And compounding that physical limit is the labor market itself. Over the last 5 years, U.S. labor costs have surged significantly, driven by broader inflation and incredibly severe worker shortages. Finding people who are willing and able to do the grueling, physically destroying, repetitive work of warehouse fulfillment has become one of the biggest bottlenecks for these companies.
Which introduces the paradigm shift of robotics as a service, or RaaS. This is the financial mechanism making agentic AI viable.
How does that work?
Well, instead of a company spending a massive amount of upfront capital to buy a fleet of robots, they essentially subscribe to the robot's labor. It shifts the entire economic model from a capital expenditure to an operational expenditure. And the advantage of this RaaS model is incredibly potent.
The first huge advantage is availability. These agentic robots do not operate on a human biological clock. They run 24 hours a day, 7 days a week, 365 days a year.
No downtime.
They don't need 15-minute coffee breaks, they don't have shift changes, they don't call in sick, and they don't suffer from fatigue at hour 9 of a shift. They only pause to autonomously navigate to a charging pad to top up their own batteries, and then they get right back to work.
And then you factor in the cost efficiency, which is perhaps the most striking data point we have. The operational cost of robotics as a service has plummeted over the last few years. It has now crossed a critical threshold where the hourly cost of operating a highly advanced thinking robot like Digit is well below the U.S. minimum hourly wage. From a purely mathematical standpoint, it is now fundamentally cheaper to subscribe to a humanoid robot than it is to pay the lowest legally permissible wage to a human worker.
That is a staggering economic reality. The math is undeniable. And the third factor pushing this transition is safety. Warehouse fulfillment has historically been plagued by a high rate of ergonomic injuries, chronic back strains, sprains, muscle exhaustion.
It takes a toll.
A huge toll. By having machines like Proteus handle the multi-ton heavy lifting and Digit handle the repetitive bending and reaching, the robots are taking over the dull, dirty, and dangerous tasks. This dramatically reduces the rate of severe physical injury on the warehouse floor.
The convergence of these factors, the demand for sub-60-minute delivery, the labor shortages, and the plunging cost of RaaS is pushing the logistics industry toward automation at breakneck speed. The financial incentives are simply too massive to ignore.
So, what does this all mean? When the math so heavily favors the machine, what happens to the human beings who have historically built their lives around these jobs? The ultimate human impact question hanging over all of this is whether workers are being upskilled or if they are becoming obsolete.
It's the big debate.
As with any massive societal shift on the scale of the Industrial Revolution, there are two very distinct perspectives. We should look at both.
Let's begin with the perspective from Amazon and the broader logistics industry. Their stance is that introducing robotics on this scale does not destroy human employment. It redefines it by creating entirely new, higher-paying categories of jobs.
The hiring data does show a shift. Amazon has actively hired thousands of new robotics, maintenance technicians, data engineers, and what they call flow control specialists. There is a photo in our stack that captures this new reality perfectly.
The one from the catwalk.
Yeah. You see this sprawling, cavernous warehouse floor. Down below, there's a sea of those blue omnidirectional robots seamlessly moving thousands of items in a complex dance. But up above, elevated on a sleek metal catwalk overlooking the floor, stands a single human worker. He is in a climate-controlled space, holding a tablet.
He's not doing the lifting.
He isn't sweating, he isn't lifting boxes, he isn't risking a back injury. He is monitoring multiple glowing digital dashboards, overseeing the flow and efficiency of the entire robotic fleet below him.
That image is a vivid representation of the upskilling argument. The human being is no longer required to be the raw muscle of the operation. The human has been elevated to be the manager of the muscle. The
Huh.
physical toll is erased, replaced by digital oversight.
Right.
However, critics of this rapid automation view this transition through a much starker lens, particularly regarding the fate of the traditional blue-collar workforce.
The critics are focused on the harsh ratio of replacement. The reality on the ground is that for every single specialized flow control specialist standing on that catwalk with an iPad, dozens of traditional picker and packer roles down on the floor vanish completely.
The numbers just don't match up.
They don't. The barrier to entry to become a data engineer or a robotics technician is incredibly high. It requires specific education and training. The barrier to entry for manually picking items off a shelf was historically low, providing a vital entry point into the workforce for millions of people.
This raises an important question regarding the future of accessible labor. When we look at the capabilities of the digit robot, specifically its ability to mimic human movement, walking, bending, and grasping with 99% accuracy, the unique value proposition of unskilled human physical labor disappears.
It's just gone.
The critics argue that because of this exact physical capability, coupled with the economics of RaaS, the unskilled labor market is facing its greatest existential threat since the dawn of the Industrial Revolution.
It is a profound and incredibly complicated tension. On one hand, you have the undeniable creation of high-tech, specialized jobs and the systematic removal of dangerous, physically destroying labor from the human experience.
Which is a good thing.
Definitely. But on the other hand, you have the rapid obsolescence of accessible entry-level blue-collar jobs that millions of families rely on to survive. Both of these realities are existing simultaneously right now in 2026.
We are navigating a complex economic reality where the very definition of labor is being rewritten in real time. This transition is not going to be seamless. The friction between the promise of upskilling and the pain of obsolescence is going to dominate labor economics and public policy discussions for the next decade.
Which brings us to the verdict for March 2026. The overriding conclusion from all of these sources and photos today is that the era of generic AI hype is officially behind us.
The milestone of 1 million active physical robots signifies a hard transition from the theoretical realm of digital chatbots into the highly practical realm of industrial application.
We are no longer sitting around debating whether a generative AI model can write a passable college essay or generate a funny picture. That was the conversation 3 years ago. Today, we are watching agentic AI physically move the United States economy.
Literally moving it.
It is utilizing computer vision, predicting human behavior, and making independent, autonomous decisions to move millions of tons of goods across millions of square feet of warehouse space.
It is the realization of physical AI at an industrial scale. And the implications of this technology ripple out far beyond the walls of any single fulfillment center.
For you, the listener, the trade-off of this robotic revolution is becoming very clear. On the consumer side, this means cheaper goods, hyper-efficiency, and impossibly fast shipping. That sub-60-minute delivery window is rapidly becoming the new baseline standard of modern life.
But there is a cost.
Yes, for Wall Street, it means wider profit margins as the operational costs fall below the minimum wage. But for the American worker, it is a very loud, very real wake-up call. The future didn't just arrive, it is already fully trained and clocking in for the next shift.
The physical world is now programmable, and that is a threshold we cannot uncross. But before we wrap up, I want to leave you with a thought that builds on everything we've unpacked today. We have spent this entire deep dive exploring how these machines, Proteus, Digit, and millions of others, are now capable of autonomous physical agency.
Right.
They are seeing, predicting, and deciding, without human permission, inside the closed, controlled environments of massive private warehouses. But if this multimodal technology has been perfected to navigate safely around unpredictable humans in a frantic high-speed logistics center, how long until that exact same autonomous physical decision-making is integrated into the public spaces you navigate every single day?
Wow.
Imagine those same agentic AI systems operating alongside you in the aisles of your local grocery store, or navigating the crosswalks and sidewalks of your city streets. The technology is no longer confined to a cage, and it is only a matter of time before the hybrid logistics model expands out of the warehouse and into the rest of the world.
That is a fascinating and slightly chilling thought to leave on. The walls of the warehouse are coming down, and the robots are walking out. I want to thank you so much for joining us on this deep dive. We've covered a massive shift today, from the rigid, path-following Kiva bots of the past to the world-perceiving Proteus and Digit models, all the way to the brutal economics driving this new era of automation. Keep questioning the world around you because, as we've seen today, the future is moving incredibly fast. Until next time.